take a look at some exponent properties. So let's look at the first example, product of powers property. So when you see something like this example here, 3 squared times 3 to the 6, or x cubed times x to the 4th, that's a product of powers property. So to multiply powers with the same base, you're going to add their exponents. So just a couple of vocabulary things is, number one, this number here, so in this example, the 3 is our base. For this other example on the right, x cubed times x to the 4th, the x is our base. So the base is whatever the exponent is attached to. Now look at that and look at this example here. We have 2x to the 3rd times 5x to the 4th. Now, the x is our base, and then the numbers 2 and 5 are our coefficients. So what we're going to do when you see something like this is you multiply the coefficients. You're going to keep one base and then add the exponent. So in this example here, 2 times 5 is 10. 2 times 5 is 10. And then you keep one base. We're going to keep the x, just one of them, and then 3 plus 4. So we're adding the exponents. We have 3 x's plus 4 x's. So total, we're going to have 10x to the 7th. Okay, so that's what you do with this type. So here, though, it looks a little different. So if we have the same base, so really what this is saying is we have 3 times 3, and then we have 3 6 times 2, 3, 4, 5, 6. So how many 3's do we have altogether? We have 8. So it's 3 to the 8th power. So that's why you can just add the exponents. We have 2 3's here, another 6. So therefore it is 8. So 3 times 2 plus 6. 3 raised to the 2 plus 6. That is our 3 to the 8th. Same thing here. So there's no coefficients to multiply. That's just 1. And then we add the exponent. So 3 plus 4 is 7. So it's x to the 7th. So quotient of powers property. To divide powers with the same base, we're just going to subtract their exponents. And then another added thing we want to remember is we have to divide or simplify the coefficients. So in this case, we have 10y to the 10th and 20y to the 7th. So our 10 and our 20, the pink, is our coefficients. So we're going to simplify or divide those. So we notice that that just becomes 1 over 2. Then we can subtract our exponents. So y to the 10th, y to the 7th. Now let's do this a long way. Y to the 10th really means I just have 10 y's. 4, 5, 6, 7, 8, 9, 10 there. And then 7 y's in the denominator. Then what we could do is cancel out the common factors, right? Y over y is just 1, so we can cancel them all out. And so notice what we're left with. We're left with 3y. So this is 1/2 y to the 3rd power. So notice that all we had to do to make this a lot faster and more efficient is that you're just going to subtract the exponents, right? 10 minus 7 is 3. So for this first example, y to the 10th over y to the 7th, we just go y, and then 10 minus 7 is y to the 3rd. Now, just as an added hint is you should always subtract from the larger exponent. So for example, just take this for example. What if I had y to the 9th on the top and y to the 12th? So what we would do is if I were to subtract the 9 from the bottom, it needs to still stay in the denominator. So what's going to happen is there's still a 1 here. And this becomes y to the 12th, and then we're going to subtract the 9. So this becomes 1 over y to the 3rd. So just be very careful about that. So again, if we were to do this along, we would write 9 y's at the top and 12 y's at the bottom. Okay, and we cancel it all out, we're going to only be left with 3 of the y's in the denominator. And notice there's still a 1 on top. You cannot change the position. Okay, this example here, -5 to the 8th and -5 to the 4th. Just subtract the exponents. We don't want to have to do extra work on that. We're just practicing on our exponent properties. So this becomes -5 all raised to the 4th power. So next we're going to find a power of a power property. So to find a power of a power, you're just going to multiply the exponent. So we have W12 to the 5th power. Now the reason why you would do that, so remember this 5 here means that I rewrite this inside 5 times, right? So y to the 12th, y to the 12th, not y, w to the 12th 5 times. Okay, this is a long way to do it. And then remember when we're multiplying, so going back to our properties from before, we would just add the number of 12s, right? 12 plus 12 plus 12 plus 12. So that would mean that it's w to the 60th. Notice that it's shorter to just say w. 12 times 5 is still w to the 60. So it's still the same answer. It's just more efficient. So in this example here, we have 6 to the negative 2 raised to the negative 5. So we're just going to multiply the exponents together. So this becomes 6 to the positive 10. And we're done. So now powers of a quotient property. So this is the type of problem I really want to look at. It's 4x squared over 3y to the 4th, and it's all raised to the 3rd power. So something to remember with something like this is, yes, when we divide powers with the same base, we subtract. We don't have the same base here. So when you have something like this, we're going to distribute the exponent to everything inside. So be very careful here. So what happens is this becomes 4 to the 3rd, and then x squared, and then again we have to multiply that 3 to it, x squared times 3, right? So we're just applying our other properties, divided by 3, don't forget, to the 3rd, and then y to the 4th, also to the 3rd. So you take this 3 and you distribute it to every single thing inside. Be very careful. So what this becomes is 4 to the 3rd power is really 64. That's 4 times 4, which is 16. 16 times 4 is 64. Then here, x 2 times 3, that's x to the 6th over 3 cubed. That's 3 times 3 times 3. So that is 27. And then y to the 4 times 3, which is 12. So let's look at these examples here. It's a little simpler, but we have 4 over 3 raised to the 5th power. So we don't want to multiply it through. We're just going to say this is 4 to the 5th over 3 to the 5th. In this case here, it's x to the 5th over y to the 4th. Negative exponent. So with negative exponents, what happens with these is if there's a negative, it moves to the other side of the fraction bar. So 4 raised to the negative 2, in order to make that a positive exponent, you move it to the other side of the fraction bar. And then we could simplify this. It's small enough. 4 squared is 16. So try number 3. It's very similar. So this becomes 1 over 3 to the 3rd power. So notice once you move it, it becomes positive, and then you multiply. So remember that's 3 times 3 times 3. So therefore this is 1 over 27. Number 13. So be careful with these. The only one that moves is whatever the negative exponent is attached to. In this case, it's only attached to the x. So therefore, this is 3 squared over x to the 5th. We could simplify it a little bit more. 3 squared is 9 over x to the 5th. Number 14. So again, the only one that moves is the one with the negative exponent attached to it. So in this case, this is going to move to the bottom. And then the p to the negative 3, that's going to go to the top. The 5 has a positive exponent, so it stays where it is. If there's nothing there, there is a positive 1 attached to it. It's just invisible. So what happens is the 5 stays where it is, the p to the 3 goes to the top, and the m goes to the bottom. Last one. Anything raised to the 0 power is 1. Okay, so it's always 1. So in this case, we have 5 to the 0, that's just 1. 45 to the 0, that's also 1. 213 raised to the 0 is 1. And over here, everything in here, it's raised to the 0 power. We could distribute, well, we don't have to, right? Anything raised to the 0 power is just 1. Down here, it gets a little tricky. So see if you can try it out on your own. So pause it. All right. So this is really 8 times x to the 0. So this belongs only to the x to the 0, and that part is 1. So therefore, this is 8. this example, so I'm going to write it out. So 3 times x to the 0 is 1, plus 3 to the 0 is 1, plus x to the 0 is also 1. So this is 3 plus 1 plus 1, which is 5. A little tricky. In this case, these are just 1, so it's 11 times 1 times 1 times z to the 10th. So this is 11z to the 10th. Number 22, this is 12 plus 1 over 1. So this answer is 13 over 1, or 13.